Welcome to the course on SolidWorks Motion. In this course, you will learn the basics of using SolidWorks Motion to help you analyze the kinematic or dynamic behavior of SolidWorks assembly models. SolidWorks Motion is a virtual prototyping tool for engineers and designers interested in understanding the performance of their assemblies. The focus of this course is on the fundamental skills and concepts central to the successful use of SolidWorks Motion. Students attending this course are expected to have completed the following: mechanical design experience, SolidWorks essentials, experience with the Windows operating system. In this course, you will learn how to build, run, and post-process SolidWorks Motion models for kinematic and dynamic simulations. You will learn how to apply gravity, a motor, force, torque, and a spring with damper to the assembly. You will also learn how to create contact conditions with and without friction between components. You will also learn how to define a design study to optimize the features of a motion study, determine various forces acting on a part, and export them from SolidWorks Motion to SolidWorks Simulation. Create, run, and post-process an event-based motion study. This course is divided into several modules. Click each module title to get a brief overview of the module. A mechanism is a mechanical device that has the purpose of transferring motion and/or force from a source to an output. Motion simulation helps to analyze such mechanisms and design new mechanisms. The motion of any system is determined by the following: mates connecting the parts, the mass and inertia properties of the components, applied forces to the system, driving motions, motors or actuators, time. In Module 2, you will learn how to create a motion study to animate the motion of an assembly and use SolidWorks Motion to simulate the physical behavior of a car jack. You will also learn how to determine the torque and power required to lift a vehicle. Module 3 will teach you how to build a proper SolidWorks Motion model. In this module, you will create local mates for a SolidWorks Motion study and use the function builder to construct functional expressions for motors and forces. You will also learn how to create and modify kinematic plots. In Module 4, you will learn about creating contacts and friction. In addition to this, you will learn about the check interference command, which will be used to detect interference between components. You will also learn about adding a spring with a damper to an assembly and analyzing the assembly with and without friction. The fifth module will teach you how to analyze the closing and latching operation of a latching mechanism. It also explains how to define forces and motors using mathematical functions. It also demonstrates how to modify plot properties. In Module 6, you will learn what curve-to-curve contact is and how to define it. You will also learn about the differences and the proper usage of the solid bodies contact and curve-to-curve contact. In Module 7, you will learn how to create a cam profile using SolidWorks Motion, create a cam part using that profile, and examine the cam motion. Module 8 will teach you how to define sensors to monitor the results of a motion study. You will also learn how to create a design study and define parameters and variables in a design study. You will also learn how to optimize the features of a motion study. In Module 9, you will learn how to create flexible mates. You will also learn how to create a rack and pinion mate and a lock mate. Along with that, you will learn how to create advanced plots. Module 10 teaches you what redundancies are and how they affect motion studies. You will also learn how to use flexible mates to automatically remove redundancies in a mechanism and understand how to build a model without redundancies. In Module 11, you will learn how to export loads from SolidWorks Motion to SolidWorks Simulation. Along with that, you will learn how to create and apply action-only moments, edit mates, and specify load-bearing faces. You will also learn how to run the structural analysis in SolidWorks Simulation and in SolidWorks Motion. In the last module, you will learn how to create sensors to trigger or stop events, create a set of tasks triggered by sensors, apply servo motors, and create events with specific timing and logic. You've reached the end of the module Course Introduction. Here are the key takeaways from the module.